Hi everybody, I hope that you guys are all doing well. I miss you guys and I'm posting this video so that we can start chapter 6 here. These first two sections in chapter 6 are a couple of the most difficult lessons that we do in calculus. So I'm going to do my best here to try to help you guys through this. And please know that if you guys have questions on anything, homework problems you're working on, something I'm saying in the video, an example that doesn't make sense to you, just reach out on Remind or Google Classroom and I will do my best to try to get back with you and clarify things. Okay, so what we're looking at in this section is we're still talking about integration, and you'll notice over here to the side I kind of have summarized sort of 6 different ways that we've already talked about how to integrate. Okay, we started with just kind of some of the basics, these top 3, and then we ended the last chapter with talking about integrating by substitution, and that would be those bottom 3 that you see there. And so we're going to kind of add to the list here. The strategy that we're going to be looking at today is called integrating by parts, and as we keep adding more ways to integrate to our list, usually the problem is more difficult, because if it can be integrated using an easier technique, we most definitely would want to do that. Okay, so I normally kind of go through the breakdown of how we arrive at this formula for what we call integrating by parts. I have that typed on the front page here, but really just to kind of save time and make these videos as concise as possible, I'm just going to jump down here to this box, which has in it what we call the formula for integrating by parts. Okay, and this formula, I know it looks really crazy. Please know that what you're seeing here on the left side of this formula represents the original problem. Okay, so you're going to be given an integration problem, and that integral u dv is representing your original problem. Okay, once you use the integration by parts formula, this is what you have here on the right side. This is, I'm going to write down almost the answer, okay, because you'll notice in that blue bubble that I circled, there's still an integration symbol, but once we use the integration by parts formula, this part that has the integration symbol, that should be something that we could pretty easily integrate. Okay, so I'm going to go ahead and move to our first example, and we're just going to kind of walk through this one slowly. I want to draw your attention to the fact that this box that's all the way on the right side, it's got steps in it that I would really encourage you to kind of reference, that kind of talk you through these problems. Okay, so your focus needs to be, first of all, at comparing this original problem to the left side of the formula. Okay, and here's what you want to do. Basically, we have 2 things that we are multiplying together in these integrals, okay? And one of them we're going to set equal to u, and the other one we're going to set equal to dv, okay? Now, how do you decide which one is u and which one is dv? Well, what you want to use kind of as a guiding rule of thumb is you want to try to choose u to be equal to something that you think you could easily take the derivative of. If it's easily differentiable, it means you could easily take the derivative of it and it would result in something maybe simpler than what it was before. Okay. Typically dv, we use that for maybe something, the other more complicated factor. Okay, so you'll notice over here, step number 1 says set expressions equal to u and dv. So this is going to be step number 1 here. Okay, I'm going to choose u to be something, and then I'm going to choose dv to be something else. Okay, now as I look at my 2 factors here, x and e to the x, it feels like x is just a little bit easier to take the derivative of because it's going to result in something pretty simple. Okay, so once I've chosen that I want u to be equal to x, in addition to e to the x being dv, the dx is always going to be attached to whatever you're setting dv equal to. Okay, so there's step number 1. Okay, now step number 2, and I'm looking over here in our box, it says since the formula, okay, the formula is really talking about the right side here. If you look at the formula, it asks you to come up with what du is and what v is, okay? See, right here is a du and here is a v, okay? But we don't have those. We have a u and we have a dv, but we don't have a v and a du, okay? So here's what you're going to do. You are going to take u, and you're going to take the derivative of u. This kind of feels like what we did whenever we were integrating by substitution, okay? So remember, we would take the derivative of that, we would set it equal to du over dx, we would say the derivative of x is 1, and then we would solve for the differential du, which in this example would just be equal to 1 dx, okay? As we find these things, I would encourage you to circle them. So here's what we're saying du equals, okay? Up here we said this is what u equals. Over here we're saying this is what dv equals. Now, we also need v. Okay, you can see in the formula here we need v. Okay, so technically what's in front of our dv is the number 1. Okay, what we're going to do is we're going to take this 1 dv, we're not going to take the derivative, we're going to integrate, and here's why. When you integrate the number 1, think about what that would integrate to. Well, it would, normally we would say it would integrate to an x, but since there's a dv to the right of it, our variable would be a v. So if we integrate the number 1, that gives us a v, which is what we need up here in our formula. Okay, so I'm going to integrate the left side, I'm going to integrate the right side here. When you integrate e to the x, you copy the original, you multiply in front by the reciprocal of the coefficient in the exponent, which is just a 1. Okay, and I'm going to refrain from putting the plus c there just for the moment. You'll see why here in just a second. Okay, and I'm going to circle that because that represents my v. And now I have all 4 of these pieces circled, which is really what I need if I'm going to make the substitution on the right side of this integration by parts formula. So I want you to look at step 3 here off to the side. It says substitute the expressions for u, dv, v, and u, du, v, and dv into the integration by parts formula. So let's write down generically the integration by parts formula. And we're going to make substitutions in for all of these symbols. And it should be everything I have circled here in purple. So on the left side, in for the u, I'm going to substitute an x. And in for the dv, I'm going to substitute e to the x dx. Okay, does everybody see where I got that from? The u was x, the dv, that was this part. I substituted those 2 things right underneath each of those. Okay, now if you look at that, see how what this left side of the formula is? Look at what that is. That is really just the original problem. Okay, now my answer, or almost my answer, is really coming from when I make the substitutions on the right side. Okay, so now I'm going to substitute in for the u, an x, substitute in for the v, e to the x, minus, I have to put this integration symbol, then the v is e to the x, and du is dx. Okay, again, everybody seeing where I'm getting these parts from? As I go to each of these sections, I'm just pulling these from each of these pieces that I have circled up above. Okay, now the reason I said before this is almost the answer is because when you do an integration problem, you should not leave in your answer an integration symbol. Okay, so what we should have here, now remember this is supposed to represent almost our answer. What we should be able to do now, though, is we should be able to, I'm just going to copy this first part down. There's nothing more for me to do with that. We should easily be able to integrate this part right here. That's actually just one of our basic formulas that we learned initially when we were integrating. Integrating e to the x, we're just copying down the original, multiplying in front by the reciprocal of the coefficient, and here's where we're going to put the plus c. Okay, so we're not going to put the plus c right here, even though we were integrating from dv to v, because in the end, we're going to put the plus c there. Okay, so I'm going to go ahead and label this left side. This is the original problem, and my answer is technically what I have on the right side there. Okay, I know this is weird. I know it feels like it's a lot. please use your notes when you guys are doing this, okay? So we're going to try one more example together, and I don't have very many problems for you to try. I just want you to get your feet wet and try a few of these here tonight, okay? We're not going to do this checking the above answer, okay? Here's the idea with this, though, that I will tell you. What you're trying to do with these problems, okay, when you do this integration by parts formula. As I mentioned, it doesn't give you a final answer, but it is kind of exchanging the original integration with another integral in hopes that that second integral is simpler, okay? Like this part here that's in the formula, that was something that we could easily have integrated. Okay. If you accidentally pick the wrong thing for u and the wrong thing for dv, you'll almost immediately know it because this part of the formula will feel like it's even more of a complicated integral than what the original one was. Okay, so let's try one more of these together. I'm going to label these steps again here for us. Okay, step 1 is where we need to pick something to be u and something to be dv. Now, I will tell you this. If natural log is an option, natural log has to be what you choose for u. And the reason is whatever you choose for u, that's what you're going to take the derivative of. And whatever you choose for dv, that's what you're going to integrate. And we have never learned yet how to integrate a natural log of x. So by default, that has to be u. Okay, that means dv is going to be the x squared, and the dx always gets attached as whatever part of what dv is equal to, okay? Okay, our second step is where we actually take the derivative of u. Now remember that for natural log, you're taking the derivative of the argument, that's a 1, over the original argument. Okay, and I'm just going to rewrite this by pulling that x up to the top like that. Okay. Oh, and I would encourage you, as you find these things, go ahead and circle them. You can see how it'll be so much easier to kind of reference back and look at these here, okay? Let's see, and so then we are going to integrate. Remember, there's a 1 in front of this dv, so when we integrate a 1, that's how we get v, and then we're adding 1 to the exponent. We're multiplying in front by the reciprocal, and we're going to refrain from the plus c for now. We'll add that in at the end. Okay, let's go ahead and write down our integration by parts formula. We're going to write this kind of generically here. That way we can easily see the substitutions we're supposed to make. Okay, over here we're doing u, that's right up here, natural log of x, and dv, that's this part over here. Now, when you write it, you know, if you want to reorder this, and I probably would in the next step, like maybe slide that in front of the natural log of x. Okay, I'm going to come over here to the right side. I'm going to grab u times v. That's this diagonal here. I kind of always remember it like that. On the right side of the formula, these get multiplied together. Okay, so I'm going to put the 1/3 x cubed in front. It's just cleaner looking that way. Okay, and then for the v du, that's kind of going this direction. Okay, so that's going to be a 1/3 x cubed x to the -1 dx. Okay, now here's where you have to be careful. You cannot integrate this until you have combined the exponents on those x's together. Okay, so I'm not going to integrate yet. I'm going to combine that, add those exponents. I'm going to make that an x squared. I'm going to come over here and just reorder this. Okay, and then now this integral, this is something that I can easily integrate. Okay, this right here, we learned how to do that very first thing we learned how to integrate. We just add 1 to our exponent. I'm going to leave a little space there. I'm going to put the reciprocal of the new exponent. Here comes the plus c. And then for my final answer, you know what, you guys actually, you don't need to keep writing this. Okay, at the very end, I would like you to label it at the end. Label this left side. Okay. But in the end here, this is going to end up being -1/9, okay, just like that. Okay, and this would be the final answer that you would have for this. Okay, that's where we're going to stop. Just to kind of get your feet wet with this, I'm going to ask that for homework you do on page 445. I'm just having you do 9 through 15 odd. Okay, so that's just 4 problems to try. Okay, and then we're going to add a few more to that tomorrow, and then you can submit it into Google Classroom. Hope you guys are doing well. Please reach out if you have questions. Thanks so much. Talk to you guys later.